In this session, we will talk about recovery in a database. In the previous session of transaction processing, we saw how a transaction can be interleaved in different fashions and what are the problems associated while interleaving these transactions. Now here we will discuss about in case a transaction fails, then how do we recover from those failures. So whenever a transaction is submitted to a database management system for execution, the system is responsible for making sure that either all the operations in the transactions are completed successfully and their effect is recorded permanently in the database. In this case, the transaction is said to be committed. But if the transaction does not have any effect on the database, then the transaction is aborted. If a transaction fails after executing some of its operations, but before executing all of them, then the operation already executed must be undone and have no lasting effect. This is in the case of an abort of a transaction. Now we will see what are the causes of transaction failure. A transaction failure can occur because of a system crash or a system error or a local error or disk failure or physical problems and catastrophes. Now what is this computer failure or a system crash? A hardware, software or a network error occurs in the computer system during the transaction execution. Hardware crashes are usually media failures. For example, failure of main memory. And what is a transaction or a system error? Some operation in the transaction may cause it to fail, such as integer overflow or division by zero. Transaction failure may also occur because of erroneous parameters or because of logical programming error. With respect to local error, during transaction execution, certain conditions may occur that are necessary for the cancellation of the transaction. For example, data for the transaction may not be found. An exception condition such as insufficient account balance in the banking database may cause a transaction such as a fund withdrawal to be cancelled. So what is a disk failure? Some disk block may lose their data because of a read or write malfunction or because of a disk read-write head crash. This may happen during a read or write operation of the transaction. Physical problems and catastrophes. This refers to an endless list of problems that includes power or air conditioning failure. Probably it could be fire or theft or overwriting of disks or tapes by mistake, or even mounting of a wrong tape by the operator. So basically these are some of the failures that can make a transaction crash. Transaction states and additional operations. So basically a transaction is an atomic unit of work that should either be completed or not completed at all. So either it is 0 or it is 1. For recovery purpose, the system needs to keep track of when each transaction starts, terminates, and commits or aborts. Therefore, the recovery manager of the database management system need to keep track of the following operation. So it keeps track of when the transaction began, whether it was a read operation or a write operation, when the transaction completed, whether the transaction was committed or the transaction was aborted. Coming to the first operation, begin transaction. This marks the beginning of a transaction execution. Next, read or write. This specifies read or write operation on the database items that are executed as part of the transaction. End transaction. This specifies that read and write transaction operation have ended and marks the end of the transaction execution. However, at this point, it may be necessary to check whether the changes introduced by the transaction can be permanently applied to the database or whether the transaction has to be aborted because it violates the serializability or for some other reason. Commit transaction. This signals a successful end of the transaction so that any changes or any updations executed by the transactions can be safely committed to the database and will not be undone. Rollback or abort. This signals that the transaction has ended unsuccessfully so that any changes or effects that the transaction may have applied to the database must be undone. Now we will discuss about the state transition diagram. The figure shows the state transition diagram and how a transaction moves through its execution states. A transaction goes into an active state immediately after it starts execution, where it can execute the read and the write operations. When the transaction ends, it moves to the partially committed state. At this point, some recovery protocols need to ensure that a system failure will not result in an inability to record the changes of the transaction permanently. Once this check is successful, the transaction is said to have reached its commit point and enters the committed state. When the transaction is committed, it has concluded its execution successfully and all its changes must be recorded permanently in the database. However, a transaction can go to the failed state if one of the check fails or if the transaction is aborted during the active state. The transaction may then have to be rolled back to undo the effects of its write operation on the database. The terminated state corresponds to the transaction leaving the system. So this is how the read and write transactions are taken care of. Coming to the system log. To be able to recover from failure that affect transactions, the system must maintain a log to keep track of all the transaction operations that affect the values of database items, as well as other transaction information that may be needed to permit recovery from failures. The log is a sequential append-only file that is kept on disk, so it is not affected by any type of failure except for disk or catastrophic failure. When the log buffer is filled or when certain other conditions occur, the log buffer is appended to the end of the log file on the disk. The following are the types of entries which are called as log records that are written to the log file and the corresponding action of each log record. Now in all these entries, the alphabet T refers to an unique transaction ID that is generated automatically by the system for each transaction and that is used to identify each transaction. Coming to the first record, that is start transaction T. Now this indicates that the transaction T has started execution. So this will be a unique ID. Next is a write transaction. So the parameters over here are write, T, X, old value and new value. Now this indicates that the transaction T has changed the value of database item X from old value to new value. Next is about read. This record indicates that the transaction T has read the value of database item X. Commit T indicates that the transaction T has completed successfully and affirms that its effect can be committed or permanently recorded in the database. And the last record is abort. Now this record indicates that the transaction T has been aborted. Coming to a very important topic of database, that is the ACID properties of the database. So where A is atomicity, C is consistency, I is isolation, and D is for durability. A transaction should possess several properties which are called as the ACID properties. They should be enforced by the concurrency control and recovery methods of the database management system. Now when we talk about atomicity, a transaction is an atomic unit of processing. It should either be performed or not performed at all. So either the transaction should be 0 or the transaction should be 1. It should not be half the way. Coming to consistency preservation, a transaction should be consistency preserving, meaning that if it is completely executed from beginning to end without interference from other transaction, it should take the database from one consistent state to another consistent state. Then your database is said to be consistency preserving. Next, about isolation. A transaction should appear as if it is being executed in isolation from other transactions, even though many transactions are executing concurrently. That is, the execution of a transaction should not be interfered by other transactions executing concurrently. And finally, coming to durability, the changes applied to the database by a committed transaction must persist in the database. These changes must not be lost because of any kind of failure.